Good morning, everybody. Next speaker is going to be Marten Smits from FHIR. He's our product owner and in charge of the Validator, the .NET SDK, and package.
Thank you. All right. Well, today we're going to talk about the FHIR Validator. First, I'm going to introduce myself a little bit. As Matt said, I'm a developer and product owner on the side, I guess, a little bit for FHIR. I'm responsible for the FHIR.Net SDK, which is our open source library, doing everything you need for FHIR in .NET. And next to that, we have a couple of helper libraries. Like one of them I'm going to talk to you about is the Validator API. And we have a package library as well. We have some more smaller ones, but less important, I guess. I've been working for 10 years at FHIR, first starting off as a consultant and then slowly growing into the developer side of things. And today it's validator time. First of all, I have a couple of questions for you, maybe, to know my audience a little bit. Who of you already uses the .NET SDK here? Right, very nice. So we're going to see a little bit of code from that. So people who don't use it, don't be scared. It's DevDays, so you need to expect it a little bit. Learning objective of today are, first I'm going to talk to you about what the .NET Validator is supposed to do, what it is. Next up, I'm going to talk, we have an old library as well. We call it the legacy now. I'm going to talk to you about the differences between the two. Then we're going to show some code, how to use it, how to set it up. We discuss some features about the validator that we have, how to use those, and why you would or wouldn't use them. And then I'm going to talk to you about slowly or quickly about how we align with the Java validator, which is out there, and how we are supposed to make those two work together or have better alignment, and then we have the same outcomes doing the same validation. And last of all, I'm going to talk about next steps. So first, the .NET Validator. It's maintained by FHIR. It's open source. Everyone can use it. It's on GitHub. And it's a .NET-based library. It's based on our SDK, so it uses the same models as that. So you need the SDK as well to run the validator. And it produced, when we publish it, it will be produced as a NuGet package, which is how Microsoft or .NET distribute their software, especially libraries in this case. And its main purpose is do profile validation, profile-based validation. For those of you who don't know what that is, we need that, right? I mean, profile validation is actually that you can validate your FHIR instance, for example, a regular patient resource or an observation resource, against the rules that have been defined for it, for example, in US Core. So here's a profile in Simplifier, in this case. So you have all these rules here for this observation. I think this is a Dutch one. Doesn't really matter. And here is a small, really simple observation resource. And what a validator does, it will check, using that profile tag over there, if it actually conforms to, if that resource actually conforms to the rules that have been defined on the left. So we'll check data types. For example, do we have the correct data type for this element? We'll check cardinality. Do I have this required element, for example, in this resource? It will check the terminology. Do I actually conform to whatever value set is based there? And it will do fixed values, etc. So actually all those rules that have been specified in this profile, it will validate those and will give you an outcome. That's what profile-based validation is, and that's what the .NET Validator is for as well. So at the end of the day, like when we validate it, it will give you a stamp like this is success, or this is an error, or this produced warnings, but it's okay still. So that's what we tend to do. And that's what we did as well. So we have this features for years already inside the SDK before. We moved those features out of the SDK, out of the main library, for probably mostly maintenance resources reasons, because what we found out is that we needed like different timelines to publish like new features for the validator, and we don't want to wait for a new SDK or whatever. So we moved those around. But when we developed a new one, we already knew that the old one was going to be replaced. So we renamed it the legacy validator immediately, but there wasn't a new one yet. So that confused a lot of people. So we had a library on the right side, on the lower right side, which called HL7 FHIR Validation Legacy, and then have the FHIR version next to it. But there wasn't a new one yet. So people were starting to wonder, what is this thing? Can I still use it? You should have still used it. But now, as of earlier this year, we actually matured our newer one and published it. And so now we have the FHIR validation in R4, which is the new one. You shouldn't use the old one anymore. The newer one it's faster. It does validation faster. It has less memory impact. And for us, that's one of the reasons we create a new one. It's more maintainable and more extendable as well. I'm going to talk to you about that later in the presentation on how that is. So don't use the old one yet. If you see it, it's still there. You can still use it, but it will not be maintained. It has some bugs in it that's already been fixed in the newer ones. So please just go for the non-legacy one. All right, now some code. So this is how you're going to have to use the new validator. Here on the lower side, you'll see this is like how you construct a new one. So first, you're going to need some sort of resource resolver. A resource resolver is a place, or it's a class actually on how you are going to resolve all of your artifacts that you'll need for validation. So value sets, structure definitions, profiles, everything where the rules are defined in. You have to need a resource resolver for that to know where it's stored and how to get it to the validator. In this case, we use the package resolver. It's pretty easy to have as an example, and it will just get you magically. It uses the package library to give you all the artifacts of US core in this case. So that's easy. We wrap it inside of a cache resolver, so it's cached, and you don't have to like get it all the time. And next to it, you need something to handle terminology. You can do this locally. You can have a local terminology service that can like validate codes locally, or you can use an external one. For example, Graham's terminology server, or whatever you have like externally. You can use it like whatever. Snowman's one. We don't really care. We just provide you a way to actually set it up. And next to that, you just create a new validator instance, like a new class, pass it the resolver and your terminology service, and you're done. So that will create a validator. So this is used for resolving artifacts. This handles all your terminology stuff. And then you'll have a validator at the end. So next up, you want to validate an actual resource. So you have your patient resource here. Call it a test patient in this case. It's empty. It will probably validate or not because it needs required elements. And then this can either be a POCO, or whoever knows what that is, like an I-typed element or element node. If you don't know what it is, be happy. You only need it in advanced use cases, but it can also take an I-typed element if you know what it is and you're worried about it. It will take the canonical URL of the structure definition that you want to validate against. It's optional, actually, because sometimes the resource already has this canonical URL, like we saw in one of the first slides. If you don't have it inside of your resource and you want to validate it against another profile, you can do it this way. And then the only thing you have to do is call the validate function of the validator, pass it those two arguments, and we'll get you an operation definition as a result. So the operation definition is a FHIR resource. which will have the result of this operation, of this validate operation in this case, inside of it. And we gave it a couple of extra fields, which are easy for you to check if it's actually correct. So we have result.success here, which will be a Boolean. And we have these integer things to see the amount of errors or warnings it will have. And we'll take a look at what this outcome will look like in the next slide. So this is, and I hope you can see it, this is the operation, an operation outcome as a result of the validator represented in JSON in this case. You will have it represented in a Microsoft POCO class as a result of the validator, but this is easy for me to share what it looks like in the slides. You can see it has, in this case, it has an error, and it says that the code is invalid. It will show you in the details part of the operation outcome more details about this error code, because code invalid will not usually be enough for you to know where to find your error. And it will have an internal code that we defined it. So in this case, it's 6007. Doesn't really matter. It's for us as well nice for debugging purposes. We have those codes in simplifier as well, so you can group them a little bit. It's more of an internal thing, but you can find out all these codes inside of the FHIR.net SDK if you need them. And next to that, it will have a location of where this error actually occurs. In this case, the code was invalid for an observation resource. The value X of that observation resource has an invalid code. And there's a human readable text just below to have even more like details on your validation. In this case, we'll say the code M is not a valid code for actually H units. It will have to be MO for months. So you'll see this observation had an invalid code in their value X. There's also a location and expression where you can see the FHIR path field of that, or where it actually occurred. So next to the easier ones on how to set up the validator, we have some optional parameters as well. You can provide it with an external reference resolver, and that is how we get you to also validate the resources that are referenced by the resource you are validating. It's a little bit complicated, maybe sounds, but for example, if you have an observation resource which has a subject that points to a patient resource, optionally, you can also let the validator validate that patient resource as well. So, for example, in US Core, you will have an observation, and they have a rule that the subject has to be a US Core patient. And they will have a reference to that patient. And the validator can follow that reference, find your patient, and see if it's actually a US Core patient. So it knows that your observation actually referenced a correct patient. This is optional. If you don't provide a resolver for this, it's a similar resolver as we use for the like the conformance artifacts, like the profiles and the value sets. It's an iResource resolver. It's an interface. You can provide it with an external external one or a local one. In this case, we've used a file-based external reference resolver. It's part of the SDK as well. And we said all of our examples, all of our instances are here on my C drive somewhere. So follow the references to that C drive, fetch the resource, validate it. Well, you get it. And next to it, you have an optional parameter, which is called settings. In the next slide, I will tell you all about some of the settings we have that you can influence the validation behavior. So these are a couple of settings that I want to discuss. It is this validation settings class here, and these are all fields that you can set or not set inside of the settings file. So constraint best practices, it determines how to deal with constraints defined in the FHIR spec or in a profile that are marked as best practice. Normally, default, it will produce a warning and we'll say from the validator, it's not actually incorrect if you don't follow a best practice, but please be aware of it. But some users would like to see a best practice failure as an error and actually have them fail the validator and say this is actually an incorrect resource because we didn't follow the best practices defined in the structure definition. And you can set that behavior using the constraint best practices field. The select meta profiles option is it determines which profiles from a resource meta field will be used to validate the instance against. Default is you can provide multiple. So for example, a patient can conform to a US score, but also to the international patient summary and also to the Dutch core profile, for example. You can all state that it conforms to all of them. But you don't want to actually, not always, you don't want to actually validate against all of them. Because for example, here in the US, you would only care about if it conforms to the US score and not if it conforms to the Dutch score profile. So this settings can let you say, I only care about the US score ones. I don't care about all the international stuff that you are saying you conform to because I don't need it. The next one is called follow extension URL. And this will say if it will actually try to resolve the extension that you have defined, that is defined in a resource. So a patient resource can have an extension. And if it doesn't know, if the validator can't resolve that extension, it will produce a warning and saying, I actually don't know if your patient is valid because you have this extension, I don't know. I can't validate the extension. And you can set that behavior. So you can say, well, if I can't fetch that extension, I want to return an error. Default, it will have for normal extensions, it will result in a warning. And for modifier extensions, which actually modify the entire meaning of your resource, if it can't fetches that extension, it will say, I'm not going to burn my hands on this. I will say this is an error because I don't know whatever this is. And this is, maybe this can be dangerous if I don't know. So I fail it. Then we have type name mapper, which is a little bit complicated, but inside of structure definitions, you can have a set of time names called just Boolean. And we put, to actually resolve it, we turn it into a canonical. And we put the HL7 base canonical prefix before it. In this case, it's hl7.org/FHIR/structure definition. But if you don't want that behavior and you want to resolve them somewhere else, you can modify this type name mapper to actually, change that validation behavior here. And at the end, you can set it actually to skip all the constraint validation inside of the structure definition. And that is when, for example, you don't want that compute time because it will have to start up the FHIR path, all of the FHIR path stuff inside of the SDK, and it can take a lot of resources, and some people don't care about it and say, well, just skip all of the manual constraints that have been put in on it. I don't only care about the cardinality and the value sets or the data types, and I don't want the additional rules that have been defined using FHIR path constraints. So I'll just skip it, and it will save me a lot of computing time. Normally, this is default. I mean, default is false. It will do this, all of it. If you don't touch it, it will work. But people want to save computing time and maybe have less correct results. You can skip this. Now, for a little bit more complicated, I want to talk about how we actually developed the validator and why it's a little bit, this is the main reason why it's faster than the legacy validator. Because we use something internally called element schema. And element schema is something that we have invented for ourselves as an internal class of the validator. And it's actually a way to express structure definitions in a more efficient way for validation. I want to express that as well. It's been used for validation only than structure definition resource itself. So a structure definition is like this flat list of element definitions, right? So child elements will be, in the structure definition resource, will be a sibling of their parent. And that makes it a little bit like less efficient for a validator to actually know where in the tree you are. So what we did for element schema, we nested those elements inside of it. And we do this conversion to element schema at compile time. So first we have this, you have this package, for example, this useScore package. We will first convert all of the structure definitions inside of it to element schemas, and then we can go through all of the rules quicker. And I'll show you an example in a minute of what an element schema looks like. It uses smaller validation blocks, and that makes it more, we can just add new blocks or new rules next to it to make stuff more efficient or extend it better, but you can also provide your own rules with it. This is what an element schema looks like, or part of an element schema, because it was too big to fit on a slide. And this is the communication element, backbone element of patient. So as you can see at the ID, it's called patient.communication. That's the element we're looking at. And we'll have children, patient.communication.id, patient.communication.extension. Well, if you know the patient resource, you know what these kinds of things are. And we'll just specify the rules that we want the validator to know about. So it doesn't care about descriptions, it doesn't care about comments, it doesn't care about everything you need, structure definition, for example, render it nicer or whatever. It's just used for validation. So it will get rid of a lot of noise from the structure definition and just have rules that we care about. And all of these elements you see here in element schema, like ID or fast invariant LO1, is actually to make the constraint called element1 validate faster. All of these will fire up a piece of code from the validator. So we'll have like these validation blocks inside of it. I will show you one in a minute. So we'll just go through the element schema, go through the resource at the same time. We'll say, okay, I have this element here, communication ID. I have to fire up those. These are the inputs I have. Let's go. It'll be really fast to do it, and it will cost a lot of less memory. Then we'll have load in all of the structure definitions and then run validation through it. This is an example, and this is also an example about how you can write your own code blocks and add it to the schema. This is called the canonical builder. So you need first an implementation of something called iSchema builder to put it in the element schema. And this only defines when I want to, I can walk you through it. So it has one function to implement, it's called build. And it needs to know, and you can see if the element, if we encounter an element ID called canonical.value, we will return a new canonical validator. And a canonical validator is something that we defined in the newer slide, but this is something you add to the iSchema builder. It will go through the structure definition and say, oh, for something called canonical value, I will need to fire up a canonical validator. And this canonical validator we have defined here. The first thing is the JToken, and it's just something to express in the element schema what it's called. So that's canonical in this case. So here, if we go back a little bit, you see the cardinality thing. For the cardinality validator, it will be called cardinality, but in this case, canonical. And then it has one function to implement, it's called validate. It will take, in this case, an iScoped node, but this is something internal we use, but it's actually a resource or an element to validate, it will have the settings from the validator, and it will have some state to keep the errors. And then in this case, it will just validate just that element if it conforms to the rules of being a valid canonical. It will first see, is this actually a string? Well, if it is, then say, is it an anchor? Is it absolute? Then it's a valid canonical. If not, if it's not an absolute URL, we'll say, well, this is not a valid canonical URL, and we'll return an error in this case. And this is also a way for you, if you use the validator, to write your own rules that we haven't defined yet, or specific rules that you want and that's not expressed in FHIR. And this is something going back. So this is, there's also, like, we have a FHIR validator in .NET stack, and the Java has a FHIR validator as well, which is, and we want to align those because we don't want people to have another experience using the Java validator than we want to have if people use the .NET validator, because that will be a really big problem, right? If you have a resource and the Java validator says it's incorrect, and we say it's correct, you don't know as a user who is right or wrong. So we try to align with the Java validator. So we have defined a common set of unit tests. There's this link here inside the slide, and you can go, it's on GitHub. And we make sure that we both actually have the same result with those unit tests. It's a long list of unit tests, like thousands of tests. But there's also a problem because it's really hard to compare the outcomes automatically, right? We both return operation definition, and we both return warnings or errors. So the result is easy to compare. You know if a resource is valid or invalid, and we produce warnings or informational ones. But you can't really compare whatever outcome text you have, because the Java validator could have written like a different sentence, probably. I mean, it's hard to align those for that, or have specific logic to actually do it, or produce more errors or more warnings of the same element. So it's hard to know where exactly we don't align, because there's like so many unit tests where we're going through them one by one. It's a really manual labor to see, and then discuss with the Java people. Okay, yeah, we see this different outcome here. Are we correct? Are you correct? Is this actually supposed to return a warning, or is it actually wrong? For example, what we discussed about the extension logic. If you can't find an extension, we say that's a warning. And the Java people could say, well, this is not a warning. We think this is actually incorrect because we can't really validate it. So we return an error, and we say, well, we can't validate it. So we don't know it's actually incorrect. So we just let the user decide themselves. So saying, we think it's valid, but this is a warning. So please check it yourself. And I think we have aligned a lot already. So I think everything defined using structured definitions is very straightforward, solid, the same results. But there are some manual rules that we have defined, or the Java validator has defined, which still differs in the outcomes a little bit. But I don't think it really matters which one of you use. They both will be pretty good in returning validation results. So this is, well, end of my presentation. We've discussed the open source .NET validator, what it is. You know, it's on GitHub. There's links in the slides on where you can find it. We've discussed how to validate, how to set it up, how you validate your resource. Please try it out for yourselves. We discussed element schema a little bit. There's also a talk about FHIR schemas, I think, in, I think, in the next session. And Ewout, my colleague Ewout, is there as well. And we will probably discuss FHIR schema and how to compare it to what we use internally as element schema. Maybe we'll use FHIR schema at the end. And next to it, this is, and you've learned how to extend the validator yourself, how we set up rules, how we use smaller code blocks to validate. And I didn't discuss the next steps yet. So next steps for our validator are to slowly open the public API. We now have only a couple of methods or a couple of functions that are really defined as public, because we still want to alter the internal ones a little bit, so we don't want to break your code if you already use them. They're actually, some of them are already public, but a little bit hidden away. So you can use them, but at your own risk. And we're going to slowly mature that, open up the public API, give you a little bit more flexibility in using it. We want to align with the Java validator more. We want to add more manual rules next to everything that's defined in structure definition ourselves. And we want to, I think the next couple of months, we're going to implement this in FHIR Terminal, in our tools, in Simplifier and in FHIR Server, because they still use the older validators. And we're going to take our time to implement it there and make sure it runs well. I think it's time for questions now. If you have more, if you want to get in touch with me, you can just email me. If you're using the new validator, find it on GitHub. The link is right there. If you have problems with it, please file an issue. We will take care of it. We will respond pretty quickly. Better even is a pull request. You can clone it. You can try it out. Discuss it on chat.phir.org. We'll be there as well to help you out. Or just tap me on the shoulder during the event if you want to try it out and want to know more. And go to Nikolai's and Ewout's talk. I think it's the next session, but I'm not really sure. So, any questions?
In the past with the legacy validators, we've had issues where we're concurrently trying to validate multiple resources, and
Right.
we've had performance degradation. Have you been able to work on some of the performance issues with that?
Right. That's what we've been working on like a lot, because the former ones didn't perform at all because we load all of the structure definition inside it, and element schema is one of the reasons that we can now safely say it performs better. So I guess you'll find that it will perform better, and I hope you do.
Thank you for your talk. So a couple of questions. The external reference, like, do you go recursively? Like, imagine I have, I don't know, medication resource that reference to an encounter,
Yes.
and then a patient.
It could.
You
Yes.
go all the way.
Yes, you go all the way. Because otherwise it wouldn't know if that medication resource is actually valid, so it will recursively validate everything, yes.
And then is it possible that to set the metadata profile to a, like, pin it to a version of a, like, let's say that, I want to compare against US core version 5.1.
Right, you can. So that's what the package resolver is about. So in this case, if you go back here to one of the first slides, I think it's this. In this case, we say we use US core 6.1 as a scope here. And you can define multiple packages there as well. So if you want to be able to resolve 5.1 or 5.0.1 inside of it as well, it will widen its scope as well. So it will try to resolve the canonical URL from your resource inside of that scope. And if you can't find it, you will need to define another scope so we can actually find it.
Hey, thank you. So I just question about the efficiency here. Do you have any number versus Java versus .NET validator?
With the Java validator compared? No, I don't have any numbers.
So how we are saying it's efficient? It means, do you have any performance number with large bundle? How much
I
time
have
it
those
took?
internally, but I don't have them on the slide. So
Okay.
I can.
Thank you.
If you want, I can get you them, but.
you validated single resource like patient or the
Right.
bundle also?
I'm sorry?
Bundle will have the list of resources,
Yes.
correct? And if you give the bundle, it will
You can
validate
also do
all the resources?
Yes,
Okay.
you could. But it will have to load the whole bundle inside of the memory, so it will be a little bit slower. But
So-
we can do it. Yeah,
Okay, thank you.
it will work.
Is there a reason why the new validator is not using async?
I think it does, actually.
Yeah, because I think took a look at the code. When you get a structure definition, right? You do the async resolver, and then you
Right.
do some code to turn the async into a non-async. So yeah, why not expose like validate async and make it async all the way down?
It's a good question. We could.
Okay. Also, yeah, currently we're using the legacy validator. We're trying to move to the new validator, but yeah, I'm still looking at some issues like it's not running correctly. So yeah, I think I'll probably hit you up at the...
Please
Issues.
file issues with it, because we are maintaining it heavily and we are looking
Yeah,
for user experience as well.
I'm
So
still trying to figure out why it fails, but yeah.
we
I
can
think-
help you with that as well. So
I
if
think-
you just tell us what you encounter and why you are
Okay.
confused a little bit, then we can help you debug it.
Okay, I'll
we're happy
hit
to
you
do.
up later.
Yes, sure, no problem.
Okay.
Thank you. So back to the operation outcome slide. Yep, that one. So have you done any mappings between, so you've got the system and code there, do you have any mappings between that and the legacy or even the Java version? So you could try and cross-reference to say that yes, this issue occurred and that's the same as the old
Right.
one, or that's the same as, to try and help with that
The
checking.
legacy one uses the same codes.
Yep.
So the codes are defined in the SDK. It's not actually defined in this library itself. So it uses the same codes. And we've been talking with Graham about aligning those codes with Java, but we haven't come to that yet.
So
But
even if we're not aligning them, if we can create a concept map or something to say this
This is the
equals
same.
that,
Will be
that
really
might actually
useful.
help with your
Right.
cross check.
that would be nice. And we
Cool.
should.
I'm happy to pitch in and help with that.
Perfect. Even better.
And yep, what was the other thing? What's the stability? So I know there's almost Christian, and I can't remember the gentleman in the front.
Right.
Had the sort of experience with it not quite right. How have you found the stability of where it is now versus the legacy one?
Right. So we've been using it for some of our customers already, and they find that the results are better than the legacy one, and it's faster and uses less memory. We haven't found a lot of downsides compared to the legacy validator in practice, so we think it's pretty stable.
Thank you so much for the presentation. I just wanted to follow up on the compile time conversion from structure definition to the element schema.
Right.
Is that when you do the package resolver, can you load new things like dynamically and it will
Right.
quote unquote compile them in the moment? Or-
Yes, you could. Yeah.
Okay, great.
Yeah.
I guess thanks for the presentation. For the performance, I guess part of the unit test, or if there were some benchmarks, and they could compare maybe with the Java unit benchmark, like performance. But we have some experience with like large bundles and cyclical references, and those, have you tested anything like that?
Right, so
Validating?
circular reference didn't work at all in the legacy validator. We would have an error with that, and we fixed that. Like we now know when there's a circular reference happening, and we just stop validating and move on to the next one, because otherwise it will just keep on validating the same thing. So we've improved that a lot. But there's no actual numbers for, we have those internally. I can I can give you them for benchmarking. But the higher and about bundles itself, like if you want to validate like a really big bundle, first we're doing is that we parse that whole bundle, like we do it through the serializer, and it will give it all in memory and will be a little bit slower. We can't do anything, well, not a lot about it. What you can do is use like what I saw is like I-typed element that will reduce that amount of memory by a lot as well. But yeah, I can help you with it if you want. Just please, if you have any issues with it, just file issues. We will heavily monitoring it and help people out, so you can improve it.
Thank you, everybody. I think that's all the time we have, but I'm sure you can find Marten out in the hallways if you have more
Please do.
questions too. Thank you.